Okay, so Chapter 6, Section 3, Domain and Range. This is probably the most important part of the section, but we are going to incorporate some of the notation that we saw previously. So first, domain. What does domain mean? Okay, well, we're on the topic of relations, so let's stick to simple variables x and y. The domain is just a description of all permissible values of x only, so we don't care about y. So if I have a graph or an equation or some way of expressing a relation, the domain is simply a description of all of the possible x values that you are allowed to use. Okay? And there's different ways of describing this. So this is not something that you have to calculate. There's no magic formula for finding the domain. You're just observing. It's kind of like looking at a person and you observe their hair color is brown. Well, you didn't really calculate anything. You just observed that their hair color was brown. That's a characteristic. So that's what domain is. It's a characteristic of a relation. It's all the possible values of x that we are allowed to use. All right, so let's look at a graph. Now here on the left, I have 3 different kinds of notation. Yes, I wish they didn't introduce so many at this stage, but they are all in the curriculum, so I will try and make them as clear and concise as possible. So what we're going to do is we're going to describe what x values are possible with this graph alone. And I'm going to show you how to describe the same thing using different kinds of notation. So here we have a relation. It is linear because it is a straight line. Now we're only talking about x values. So I don't care what's going on up or down with y. So we just care about horizontally, left and right. So the graph goes as far left as x is -7. Okay, so that's kind of where it starts. So I'll just put an imaginary thing to work. There we go. And how far to the right does it go? Well, it's continuous, and it stops at 9. Now, it's not an accident that this is an open circle, that this is white and this is black. If you see a white dot or an open circle, what that means is that specific point is not included. So think of the line as getting really, really, really close to this point. Infinitely close, as close as you want, but you can't quite get there. On the other hand, because this point is colored in dark, it's black, that means that x equals -7, that x value, that is included in this line. Okay? So we have all values in between. Okay? So all of those x values are permissible. So those are the only x values in the domain of this relation. Okay? X equals -9. That's way out here. Okay? The graph stops there. So -9 as an x value is not in the domain. So how do we describe this using number line notation? Well, that's actually what I did here. Okay, so -7 is about here. It's included, so I'll make it colored. And then over here, it goes as far right as +9, but that's not included. There we go, so make it open. Now you can connect them by going along the number line itself, or sometimes people just do this. They just go up a little bit and go over, kind of like that. It's up to you which you choose. And it's probably a good idea to label where these are. So this is 9, and this is at -7. So this is number line notation of describing what values of x are possible. So this is more visual. All right. So we know our domain is all x values between -7 inclusive and +9 not inclusive. So how do we say this in what we call set notation? Okay. Well, first of all, before I actually fill this in, whenever you see these rounded sets of brackets, that is used to denote a set. A set or a collection of numbers. Okay, so if you see these brackets, it means we're talking about a set. And this bar here, this vertical bar, that actually, kind of like epsilon, has a meaning in English, but it's only 2 words. It means such that. So instead of writing the words such that, we can write that bar. Okay. So how do we say this in set notation? Well, we do it like this. Domain is x. So we put x right here. So it just tells us which variable we're dealing with. Okay. In this part here, okay, to the left of this comma, that's where the important information goes. That's what actually tells us where our endpoints are, so to speak. So the leftmost point is -7. The rightmost point is 9. X is, of course, any value in between. And then we use our old friends, the inequalities. So it's like the old Pac-Man mouths. And they always open the bigger number. And the only other thing we have to be careful of is the 9 is not included. Okay, so this is fine. But because the -7 is included, I must put a little line underneath that. So this says that the domain is any x value such that I'm greater than or equal to -7, but at the same time I'm strictly less than 9. Okay, that's what this says in English. So it's like a sandwich. And then here we just put what types of numbers can they be. Okay, can x only be integers? Well, no, we have a solid line here. It could be any decimal or any number in between here. So x can be any real number we choose. So we say x is an element of the set of real numbers. All right, so the last notation is probably the simplest. It's interval notation. Okay, so basically all we look at are the endpoints, and we have two different kinds of brackets that we use, square and round. So our leftmost point was -7. Our rightmost point was 9. Now, 9 was not included, so we put a rounded bracket there. -7, however, it is included, so we actually do a square bracket. There we go. I'm not a particular fan of this notation because you can get it confused with an actual xy coordinate, particularly if this was also open as well. You might think that's an x value and that's a y value. So I'm not a huge fan of this notation, but it is sometimes used, so there it is. All right, let's move on to range now. Range is just like domain, right? Except domain was specific to x values, so range is specific to y values. So again, range is just a description, so it's not something you need to go out and calculate. There's no magic formula for finding the range of something. You're just describing what you see. And range is a description of all obtainable values of y. Remember, domain was for x, range is for y. So all of the dependent values. So let's look at our relation here on the graph. Well, we have a linear relation because it's a straight line, but it's a little bit different. We have an endpoint here. It's also shaded in dark, so that means that it's included. But we have an arrow here. So actually, this is what's called a ray. It's a line that has a starting point, but it has no endpoint. So we're only talking about y values. So how far up does this go? It only goes up to y is equal to 9. And it's included, so I made it dark. And the graph just goes down, down, down forever, and it never stops. So I'm not going to have some minimum point, so I just have an arrow. It tells me it goes on and on. All right, so how do I say this using number line notation? Well, I actually already have. I've just flipped it on its side. So the y values go up to 9, and they include 9. So put that 9 there. However, there's no left bound. Okay, it can go as negative as we want. Okay, remember it goes down forever. So we say that just by drawing a line like that with an arrow. It doesn't matter how long you make this line. You can make it short or long. It really doesn't matter. Okay. All right, how do we say this using set notation? Okay. Well, we're talking about the range. So the range is the set of all y values such that, what's our condition? Well, we have to be, y has to be less than 9. Okay, but it can be equal to 9, so we can put a line under here. But there's no point on the left, okay? So we actually leave it blank, okay? So this just says, as long as my y value is less than or equal to 9, I'm in the range. And this here just tells us what types of numbers y can be. Are we only talking integers, rational numbers, real numbers? Well, this is continuous, so of course it's all real numbers. Any real number that you can imagine, as long as it's less than or equal to 9, it's in the range. All right, interval notation. Okay, how do we use that? Well, we know that it goes as far to the right as 9, and it's included, so we use a square bracket. Well, what do we use on the left if there's no number here? Well, it's in this notation that we are allowed to use the symbol infinity. But remember, this can go as far negative as we want. So this is negative infinity. Okay? Remember, infinity is not a number. It's not a number that you can reach someday. In fact, infinity is just an idea. Okay? It's the idea of numbers having no end. So because infinity is not a number that you can reach, it's not a number at all, this must always be rounded. Always, always, always. Because if it was square, that would suggest that, well, we could reach our leftmost point of negative infinity and then we can't go any further. All right, so anytime you have a symbol of infinity, no matter which side, it's always rounded. So I'll just put that here. Rounded bracket. So there we go.